Now the second category for the types of follower motions, which is simple harmonic motion, SHM, which means simple harmonic motion. Simple harmonic motion. Before that, this simple harmonic motion is recommended for the follower motion when the cam rotates at slow speed. Even we can recommend this simple harmonic motion for moderate speed also, right? This is recommended for low speed and moderate speed, right? So let me tell you what is meant by simple harmonic motion. Simple harmonic motion, which means when a body rotates with uniform angular velocity, its projections on the diameter will have the same, will have simple harmonic motion, right? Like this. For example, take a coin and mark any one point and allow that coin to rotate 360 degree with a flat surface and trace that particular point, and you will get a simple harmonic motion like this, right? The velocity of the projection will be maximum at the center of this curve and the ends at the and zeros at ends, right? So maximum, the velocity of the projection will be maximum at the center and 0 at ends. Even for the acceleration, retardation will be 0 at center and maximum at the ends, right? For simple harmonic motion, the motion of the follower is same during outstroke and even for return stroke also, right? So this is how we are going to draw the diagram, right? First draw the circle with the diameter which is equal to the displacement of the follower, and divide this semicircle into n number of equal parts. For example, say this is 0, 1, 2, 3, 4, 5 and 6, right? Number of even equal parts, say for example 6 or 8. 6 is optimum value, and divide the outstroke angle and return stroke angle into the same number of equal parts. Here we divided into 6, then we should divide this outstroke and return stroke into 6 parts. See, for example, here A, B, C, D, E, F, that is 6, and they divided 0 to 6. 6 segments are there, 1, 2, 3, 4, 5, 6. Similar to that, here 1, 2, 3, 4, 5, 6 segments are there, right? And project the intercepts of the semicircle to corresponding divisions on the cam displacement intervals. Mark the points of intersections, for example, A, B, C, D. See, here we have to draw the circle. I mean, here we have to draw the parallel line from each divisions. Say for example, A is first division, we have to draw the horizontal line from division A and do the same for division B, division C, division D, division E and division F, right? And see, instead of A, give the name 1, 2, 3, 4, 5, 6, right? So you see in the first horizontal line, and it cuts the first vertical line, and mark the point B. And see, second horizontal line, it cuts the second vertical line, see, mark C, right? And third horizontal line, cutting the third vertical line, the point which is called as D, right? The point which is E for the fourth vertical line and fourth horizontal line is the cutting point, right? The fifth horizontal line and fifth vertical line, cutting point which is called as F, and similar for G also, right? Similar to that, mark the points for return stroke and trace all the points, and you will get the simple harmonic motion. Okay, so let us try with one example. I want to read the problem. How to draw the displacement diagram for simple harmonic motion, right? So follower lift is 40 mm with simple harmonic motion. So displacement which is equal to 40 mm for this particular follower, and during 90 degree of cam rotation. So outstroke which is equal to 90 degree. This is first sequence. We have to follow the sequence. Next, the dwell for the next 30 degree. So theta D which is equal to 30 degree, and the follower returns its original position with simple harmonic motion during the next 60 degree. So return stroke which is equal to 60 degree, right? And remaining which is dwell, right? Dwell which is equal to remaining. So we have to follow the sequence, right? What they given in the problem, right? They given first 90 degree outstroke, that next 30 dwell, next 60 degree return stroke, and remaining dwell, right? We have to follow this sequence. See, first we have to take 90 degree and 30 degree for dwell and 60 degree for return stroke and 180 for rest of the period, which is called as a dwell, right? The displacement which is equal to 40 mm as we discussed in the previous slide, what they given in the problem, right? And first draw the circle, semicircle with the diameter which is equal to 40 mm, and divide the circle into number of 6 parts. This is first, second, third, fourth, fifth and 6, right? So this is 1, 2, 3, 4, 5, this is O 1, 2, 3, 4, 5, 6, right? We divide into 6 parts. Then we have to divide this outstroke and return stroke into 6 parts. See, first segment, second segment, third, fourth segment, fifth and sixth segment. Similar to that, we have to divide here 1 to 6, right? Now see, 0, 0 cutting here, and the first point and first point cutting at point B, and similar to that, second point, third point, fourth point, fifth point and sixth point, and trace the line, you will get SHM, right? So let us see how to draw this in the software, but here I am using software, but you have to do manually, right? See, now I am going to draw the simple harmonic motion, the displacement diagram for the simple harmonic motion of the follower. I mean follower motion, which is simple harmonic motion. The displacement diagram for the follower motion called the simple harmonic motion, right? I am dividing outstroke, then 12, 30 and 60 degree for return stroke, and rest of the period are 12. Okay. Now I want to mark the dimensions. Divide. Now I want to divide that outstroke into n number of equal parts. Say 6 is optimum value. So now draw the vertical lines from each segments, each parts. So before that, I want to change the arrowheads dimensions. Now see the dimensions of the outstroke, which is 90 degree. So here scale is 1 degree, which is equal to 1 mm. So for outstroke, we have to draw the 90 mm line. For dwell, 30 mm line. For return stroke, 60 mm line. Right. So displacement, which is equal to 40. Now already we divided the outstroke into 6 parts. So now I am now I am going to trim the lines. So now I want to divide the return stroke into 6 parts. Say 6. Yes. Now draw the line from each part, each point. So I want to trim all the lines. So as we discussed, SHM, which means we have to draw the semicircle with the diameter which is equal to 40, because displacement which is equal to 40 here. So again we need to divide that semicircle into 6 parts, because already we divided the outstroke and return stroke into 6 parts. That's why here we need to divide that semicircle into 6 parts. See, we divided, and now I am joining a line from each part. Yes. Now draw the horizontal line from each points, each divisions. The dwell is not necessary. We should concentrate more on outstroke and return stroke. Right? Don't bother about dwell. No need to draw the line for dwell. Here, see the extra lines. Yes, I am deleting the extra lines. Here for dwell also I am deleting the lines. Yes. Now trace the points. Already we know that how to trace the points, the horizontal line and the vertical line. Both are cutting the points. So we should trace that points. So first horizontal line, first vertical line. That is one point. See, this is 0 and this second point, third point, fourth line with fourth division, fifth line with fifth, sixth line with sixth, last one. Okay. So this is simple harmonic motion. Then dual, okay, we have to write that, we have to draw the line. Again for return stroke, we have to draw the same, right? Seventh line, seventh point, eighth horizontal line, eighth vertical line, ninth horizontal line, ninth vertical line, 10th horizontal line, 10th vertical line. Okay, so like that. This is dual. See, now I am going to give the name. See, yes, instead of A, if you want to give numbers, you can give numbers. This is not compulsory. If you want to give alphabets, you can give alphabets. If you want to give numerical values, you can give numerical values. That is your wish. B, next one is C. E, F, G. So I want to give the name for horizontal lines also. I mean horizontal line with vertical line, that cutting point, right? This is for return stroke. Last point for dual. So this is B, right? C. The cutting point already we marked. C, B, B, C, C, D, D, E, E, F, F and G, G, right? We traced that points also. Yes, that is AA and BB, right? Yes, BB, that is B point. So I want to change into yes, B. Next, CC. Next, DD. Already we marked and curve is also completed anyway. So we should give the name before tracing the point. Next, point EE. In order to avoid the confusions, before tracing the point, you should give the names, right? That is my recommendation. In the reverse, the outstroke is completed. Now we are going to draw for return stroke. Point H, I, J, next K, next point K, next K, L, M. Okay. Yes. So A to G over for outstroke. Now we have to start from H to the N for return stroke. That is H actually, okay? H. So I, that is point I. So the intersection of J, that is J. And the point in the intersection of KK, which is called as point K. And the point, the intersection of point LL, that is called as L. Then the point intersection of the line M and M, which is M. The last one is small n. This for last one is O. So this is the way we should draw the displacement diagram with uniform, simple harmonic motion. So in manual drawing we should mention the dimension and which one is dual, which one is return stroke, which one is outstroke, that we should mention, right? And don't forget to write all the dimensions are in mm. No need to mention mm everywhere. Clear? So that you should concentrate in the manual drawing. Yeah, this is return stroke. The last one is dual. Okay, thank you.